from CLSC, and he will talk about ANUBIS.
Okay, so switching gears a little bit, and I feel it's not quite fair that there are 3 DESI talks, and therefore they get 30 minutes compared to myself and Lozano who just get 10 each. That's the first point I want to make. The second point I want to make is for the community survey, I'm actually slightly agnostic as to which survey gets selected, as long as it's MegaChem, because I know I'll be involved in pretty much anything that goes forward. That said, I have a favorite, and this is it. The acronym says it's all Northern U-band imaging survey. And so it starts with PAN-STARRS, which covers the northern sky, and GRIZ-Y. And then there's that, and then there's actually J and K over the entire northern sky as well from UCURT. It has done a series of surveys shown here that have now finally mapped out the entire northern sky. And then if you take, this is a snapshot of all the U-band data that has ever been taken by CFHT. It covers a lot, but not the whole northern sky. And this is a plot showing both the old U-band filter from pre-2015 and the new U-band filter post then, which is mostly CFIS, of course. And then by the end of CFIS / unions, that will what the coverage looks like. So this is U-band, new U-band only, all the archival data, all the planned CFIS data, and it looks like this. And so ANUBIS, what's excluded here is effectively the galactic plane, because by design, CFIS and unions are avoiding the galactic plane because it's been targeted for stellar streams, but also overlap with Euclid and overlap with all the various cosmology surveys that have gone on over the years. So it's to push down into the plane. And so there's actually 2 different proposals here. This is sort of the slightly harder one to plot, which is, let's call it ANUBIS 1, which goes down to within 5 degrees of the galactic plane. ANUBIS 2 is to go right down into the center of the plane, cover the whole northern sky, even those little gaps on the side. And the reason why there are 2 of them is because at low galactic latitude, PAN-STARRS becomes confusion limited, and so the utility of it gets lowered. Jean Mengier from PAN-STARRS tried to talk me out of this completely. I think he's much more pessimistic than he should be. I've been looking at the actual data that's available, the 3Pi survey. It looks like you can go much further into the plane than just 5 degrees, which is sort of the safe limit. And then so the coverage is north of 15, because everything south of 15 will be covered by LSST, and south of 80. And so the depths are well matched over these filters. You have CFHT at 25-ish, a little bit shallower than that. The PAN-STARRS filters, and then the UCURT filters as well. And although the numbers are much smaller for the UCURT because of the source density is roughly the same on all these filters. So it can't be just complete the set, although that's actually one of my strongest personal motivations is if you've got almost all the pieces, you're missing one part of the stamp collection, you should get the other ones. And so why should we go down into the galactic plane? This figure is taken from Bata et al., which is based on Gaia, and it's showing all the stellar streams that he identified with StreamFinder. This would actually go 5 magnitudes deeper than Gaia, however, so you'd find an awful lot of more exciting stuff. At the same time, Gaia, you can also look at the stellar populations, and this was the main motivating factor behind Luau, and you can measure metallicity 2.2 decks, get photometric distance of but down sort of closer into where things get a little bit more interesting near the galactic plane. And then if you go right into the galactic plane itself, now you can go and take a page from the Castor, which is a proposed UV satellite. You go to the Castor science cases and start cribbing stuff out. And I've cribbed a couple of things out, which are roughly divided into finding weird objects. So these things like stripped HE stars and Quinian stars, and just be able to pick those out of the billion or so objects you're going to find. And then, but also doing sort of more systematic things like actually, there's going to be a bunch of UV extinction, which you're going to measure as opposed to be annoyed by as you do this survey. Okay, so the proposed plan is basically repeat the same observing strategy for luau and CFHT. Gains 3 times 80-second exposures, do calibration with Gaia spectra, which works everywhere. Mild atmospheric extinction is acceptable, and it doesn't need to be perfectly photometric. So it is sort of robust against less than perfect conditions. And the seeing doesn't have to be perfect either. That's the conditions that we ran luau and CFHT on, and it's worked just fine. If you do the math, do the spherical geometry, the area, if you do the ANUBIS 1 north of sort of above galactic latitude of 5, you get 4,800 square degrees. And that works out neatly with 80 seconds plus overheads, 3 times 3 to, you just divide that by 10 to figure out the number of hours. And you extend down to the galactic plane, that becomes 6,200 square degrees. The other thing that was missing from I thought the DESI survey is a risk register where you identify all the problems, so you can at least see if there are things that you can you'd understand what potential issues might have, and see if and either de-risk them or learn to live with the risk. So the U-band mapping speed has been very fast for the last 3-4 runs. I'll show a couple of slides in a moment. Actually, I'll just show those slides now. So this is what the U-band coverage looked like in January for Unions, and this is what it looks like as of Sunday. Okay, so as we discussed a little bit earlier, the last 3-4 runs at CFHT have been fantastic, and if it continues like that, and as I said, the reason why it's fast is because everything has been working perfectly. No problems with the detector, no problems with cranes, no problems with the mirror, no bad weather, and also very little competition. And so the thing of, just go back here a little bit. Yeah, so the it's compatible with some surveys where now that we're observing off the galactic North Galactic Cap, it's compatible with something like Alessandro's survey, but not necessarily with we'd have to explore it a little bit more closely if it was compatible with the DESI survey that's being proposed. And then the other risk is tracking the U-band 0 point over the years. So there was a bit of a crisis about 5 years ago where the mirror coding of CFHT was degrading such the U-band sensitivity was dropping, and it's starting to drop again. It's not as bad as before, but it needs to be kept a look at. And then, and then the final one is the calibration, as discussed, requires Gaia. That should work right through the galactic plane, but there may be some small middle issues that don't work. So before putting in a proposal, I would want at least 2 hours of observations on a very photometric night to make sure that the calibration process can work before committing to a multiband survey. So I'll just leave that up as a summary and take questions.
So questions? So in the wide footprint, so you have luau and onions.
Yeah,
observation. So luau is much shallower.
No, it's exactly the same. 80 seconds times 2.
Something to know is
everything.
So it's not deeper than that. Okay, I should know, but
yeah, CFHT was basically just luau.
Okay,
trust me.
And this really help for photosy.
What's that?
This really help for the photosy up to redshift 1 or something.
Well, so the scientific motivations. I mean, yes, in principle, but the scientific motivations have to be targeted towards the local universe. LSST, Unions of the South, as it's known, LSST is going to do all the extra high redshift stuff. This is going to add a very small area to the total area that's surveyed and the root in. It's just root in statistics. It's got to be motivated by something where the north is not the same as the south, which of course it is not. The south has the galactic falls. This galactic plane survey is out on the edges towards away from the center. And it's, it's where Andromeda is, and it's where,
I'm not sure Euclid will agree with your argument. Is that a point? I'm not sure Euclid will agree with your point.
Okay,
that the north is more.
Okay, but so Euclid is... Euclid already has its U-band. Like all the footprint covered by Euclid will be covered, it will be covered by unions by the end of it, by definition.
But as the depth of the well.
Yes.
Okay.
It's kind of the whole, by design.
Other questions? Oh, okay. Thank you.
Okay.